Thank you. I think nothing rounds out a hot day in the Maldives like talking about waste. So thanks for your indulgence. Before we actually dive into the subject of the presentation, I feel like I should give a little bit of context for my involvement, just because it's fairly obvious why Richard would get up and talk to you about air travel, but maybe less so why I would be talking to you about this subject. And when I looked at the list of who was involved in the symposium, and I thought, well, maybe this is a group of people who have had their heads down in the books and in the computers so much that they don't engage much with pop culture, and I can just talk as a waste treatment aficionado. But since there's evidence that some of you have occasionally popped in a DVD and seen me mucking around in a movie now and then, I feel like I want to give you a little context for how this came to be my main occupation. I'd say, you know, look at me as somebody who moonlights occasionally in film work away from what's become my main passion and occupation, which are addressing sustainability and conservation issues from many angles, philanthropic, advocacy-wise, and also entrepreneurially. I think in terms of advocacy, I've been serving for the last couple years as the United Nations Ambassador for the Biodiversity Program, attached to the Convention on Biodiversity and the UN Environment Program. I've worked for many, many years in an activist, philanthropic sense on some very, very exciting projects in the area of community economic development and conservation. And Basswood is the most entrepreneurial side of my engagement with many of the issues that have been discussed here over the last 2 days. A number of years ago, a group of us who were interested in the entrepreneurial and investment side of grappling with some of the thorniest issues involving greenhouse gas reduction, more sustainable infrastructure and technology, came together around the very brilliant and visionary work of an engineer and biochemist named Paul Baskis. We seed funded his work and out of it built a company to provide a very cutting edge and different technological approach to waste treatment on a municipal, industrial, agricultural scale. And along with sort of the technology that we offer, we've made it a mission as a company to try to address also the underlying game theory and strategy of the way that waste treatment is addressed and approached strategically within numerous contexts: private industry, private sector tourism, municipal, and also agricultural, each of which contains its own thorny problems and obstructions to doing what we know nature does a very good job of, which is turning organic waste into non-toxic inorganics. We just haven't figured out in our history of humanity how to replicate that very efficient and effective process that nature does so well. This is largely, this is not an issue of understanding organic chemistry, because most organic chemists can explain to you very easily, any graduate student can explain to you how a cow craps in a field and it doesn't become toxic cellulosic sludge, but rather healthy soil. But we have had a problem of population, aggregation, volume, and systems management in terms of how do we most effectively replicate that natural process and create positive positive end of cycle results instead of expensive and toxic problems. So with that introduction, I think what I'd like to do is discuss a little bit our view of, give a little bit of an overview on what we all know on a basic level is a problem, which is the incredible global crisis of wastewater management and its ramifications and implications. Talk a little bit about the current state of the technology that we see out there, and then I'm going to let our CEO, Mike Walker, give you a little bit more of a dissection of the differentiation between the baseline technology that the world has been using up to now and then what we see as a happier vision of the future, both technologically and strategically, in terms of dealing with wastewater. Skip through that. You know, more people in the world today have cell phones than they have access to a working toilet. 1 in 8 people on this planet still don't have access to safe drinking water, and this is despite the fact that more than half the diseases in the world we know are caused by unclean water. Worldwide, it's nearly 1.1 billion people lack access to safe water. Only 62% of the world's population has access to improved sanitation technology, which is defined as a sanitation facility that ensures hygienic separation of human waste from human contact. 1.2 billion people have no waste facility available to them at all. Of the 60 million people that get added to the population centers of towns and cities every year, most of them occupy slums and shanty towns that have no sanitation facility. So we're moving incredible volumes of people into concentrated situations with no waste treatment solution. And even though human development is more closely linked to access to water and sanitation than any other sector, including health, education, or access to energy, this sector is in some ways the one facing, being offered, we think, the fewest new innovative solutions. Let's talk about a little bit about the health effects of a lack of good sanitation and wastewater treatment. 88% of cases of diarrhea worldwide attributable to unsafe water, inadequate sanitation, or insufficient hygiene. 1.7 million people every year dying from diarrheal diseases. 90% of all deaths caused by diarrheal diseases are children under 5 years of age, almost all in developing countries. And it's estimated that improving sanitation facilities would reduce diarrhea-related deaths in young children by more than 1/3. Investments in safe drinking water and sanitation is known to contribute to economic growth. The World Health Organization estimates that for every dollar invested in drinking water and sanitation, $3 to $34, depending on regions and technology, is returned to the national economy. An incredible statistic about lost productivity. In the developing world, in just one day, more than 200 million hours of women's time is consumed for collecting water for domestic use. This lost productivity is calculated to be greater than the combined number of working hours worked in a week by employees at Walmart, UPS, McDonald's, IBM, Target, and Kroger. This is according to water.org. More than 80% of sewage in developing countries is discharged untreated into rivers, lakes, and coastal areas. And as you guys know well, tourists use approximately 8 times more water than a day than most residents. So we know that we've got a major global problem, not a tertiary problem, not a problem that radiates off of others, but a problem that is arguably basal to a lot of our other challenges in terms of development, human health. the obstruction that a lack of waste treatment and wastewater infrastructure represents is it's an enormous impediment to a lot of what we're trying to achieve, both in terms of environmental conservation and human development and human health. So what's the landscape? What are the different landscapes in which we're facing this problem? Well, looking at the United States, arguably one of the most developed countries in the world, massive water infrastructure overhaul is needed. The EPA, Environmental Protection Agency of the United States, estimates that up to $1 trillion of investment is needed over the next 20 years to upgrade municipal waste treatment capacity. 35% of all treatment plants in the United States, roughly 18,000 sites, are currently violating EPA standards and under some form of litigation or consent order. Cost of EPA compliance is completely unaffordable to most cities and towns in the United States, which are drowning under budgetary shortfalls, and the federal government won't foot this bill. So you have an incredibly intractable problem in a developed country like the United States. So what's the developing world scenario? Well, obviously a similar situation in terms of investment needed to upgrade outmoded legacy facilities, the same as in the developed world. Environmental, economic, logistical challenges of implementing the collection systems that are needed to support any new centralized waste treatment projects. Obviously, in many cases, you just don't have the pipe laid to bring it into any kind of centralized facility. This is compounded by dense city and the growth of urban populations with no existing collection infrastructure. So you end up with a lot of people still in need of the most basic forms of sanitation. There's an estimate that there are 17,000 towns and villages in China alone that have no current sanitation option. On the other hand, in the developing world, there are interesting and ironic opportunities to be taken in. There's a tremendous opportunity in many of the countries that have the lowest baseline technology to embrace new technologies and architectures and vault over some of the outmoded infrastructure that the Western world is and the developed world is unfortunately shackled to. There's increasing economic strength in some of these countries to develop, implement and invest in new infrastructure projects. These countries are going to get to benefit from 75 years of experience in the developed world with waste treatment and its inefficiencies, and hopefully improve on them. And there's definitely an increased demand from the citizenry of in developing world countries and an expectation that basic sanitation is going to get provided, and an increasing demand for that as a priority. Looking at, because we're here at this Six Senses resort, we also thought it's worth looking at sort of what do we see as the baseline in most resort scenarios. As is the case in the Maldives, ocean dumping of untreated waste is the standard worldwide. No regulations banning or restricting discharge of effluent into the oceans, no risk of fines, no economic, direct external economic demand on the tourism industry. Most current package plants that are offered require significant amounts of energy and almost universally produce higher effluent levels on the end of pipe that are not suitable for water reuse. So in places like the Maldives, where a lot of people are doing desalination, they're not even getting secondary reuse out of the water because it's not coming out of the waste stream at a high enough quality of treatment. Leach field technology requires a lot of acreage and doesn't necessarily scale well in large population centers. You have septic tanks that leak and contaminate groundwater and ocean water, especially in situations like the Maldives where you have shallow groundwater. And as I said, water reuse very, very rarely incorporated into the waste treatment platform. So in many ways, we're looking at a grim landscape almost across the board, from private sector scenarios to municipal scenarios. Developing world has a certain set of problems. The developed world has a different set of problems. Everybody is facing what's increasingly amounting to a global crisis that's interconnected with many of the other issues that we define as our most pressing issues, and many of those issues insoluble in some sense until we grapple with this underlying issue of waste treatment. So I think what I'm going to do now is hand it over to Mike, because he's going to give an overview, an actual look into what represents the technological baseline that has been the way we have been dealing with it, or rather failing to deal with it, and what we think the future holds in terms of promising new technologies and strategies for grappling with this problem.
I went to Shanghai last year for the Chinese water show in anticipation of seeing the latest in wastewater technology. Given the size of the country's infrastructure spend, I assumed the best and the brightest new technologies were going to be at the show. What I saw was pretty much more of the same technologies that Edward had just noted are in need of $1 trillion in the West to fix, plus a lot of pumps and a lot of blowers, but not a lot of new technology. The good news was that there's a real push for waste to energy, and I think we're going to talk about that tomorrow. Energy innovation with regard to most existing technologies was a software program that reduced the plant's energy load by 3%, so nothing significant. We know that there's a lot of innovation in the wastewater treatment space, as we've seen it firsthand every day. However, what is being pushed to the developing world is a lot of the same technology by the same big development companies. They have one or two tools in their tool belt, and that is what they're going to offer, and they're racing the developing world to get it there. Outside of membrane technology, there has been no significant wastewater treatment breakthroughs that have been either widely implemented or adopted since the mid-1970s. The typical treatment protocols are aerobic digestion, moving bed bioreactors, membrane bioreactors, anaerobic digestion should also be on that list. So what are the characteristics of centralized wastewater treatment? You have significant energy use, high capital expenditures, extremely expensive upfront costs, and collection systems. So what we sometimes forget when we're doing wastewater treatment is the idea that you have to put in all the costs and footprint to get the collection, the water there. So it's a significant investment in cost and energy. They produce a tremendous amount of sludge. Perhaps the glory of the wastewater treatment system is the sludge. Long construction times, specialized labor needed to operate and maintain. It's inflexible, and this is one of the biggest keys that we talk about, because you have to size today what your needs are for tomorrow. And you know, we talk about a 20-year plan. It's really hard to get an idea on exactly what your wastewater treatment needs and footprint needs are going to be 20 years out, but you have to commit to that now. And if you don't get it right, you're hosed. So, and then if anything, one of the biggest drivers now is outside of perhaps Singapore and ironically Orange County, California, there's not a lot of wastewater reuse going on. Wastewater treatment is viewed as treating wastewater. It's not viewed as a vehicle to produce reuse water. And that's the seismic shift that we believe is going to have to happen. So when you talk about energy consumption, more than 4% of the total energy use in the U.S. is to convey and treat wastewater. And that's a significant number. In Massachusetts alone, wastewater treatment accounts for 7.4% of the industrial load. From a greenhouse gas perspective, you can see that wastewater treatment is a significant contributor to greenhouse gases. Massachusetts, again, alone contributes 619,000 tons of CO2 in 1 year. And sludge. Sludge is what it sounds like it is. Currently, the U.S. produces 7.7 million pounds, or tons rather, of sludge annually. Sludge is the byproduct of primary treatment. You see it if you were to go out to the waste facility here. Primary treatment, you hit the waste the first time, you knock it down, and then what happens is you have this big, ugly piece called sludge that's expensive, that you have to, in New York, they put it on a barge and truck it, and send it down the river. In Los Angeles, they send diesel trucks full of sludge from Los Angeles to Bakersfield every day. Think about the impact on that from a greenhouse gas perspective. All right, these are pretty pictures of sludge. Now you know my pain. And this is what happens when you deal with sludge. You're talking about runoff, you're talking about groundwater contamination. Okay, so what are we talking about? You know, when we talk about Basswood, where do we see this going? Where's the breakthrough on it? And what we believe is that a distributed network. And what is a distributed network? Think distributed computing. Spreading the power of treatment across the system increases treatment efficacy, lowers mishap risk, reduces infrastructure costs, and facilitates water reuse at the source of need. It is also at the core of the vision for the wastewater treatment going forward. All right, so this is your typical, wastewater treatment plant and the area in which it's supposed to serve. So you build the wastewater treatment plant, and then you have to actually build the infrastructure out to support it. And that infrastructure is going to cost you a considerable amount of energy and time. And you have to actually finance all that stuff out from the very beginning. To put in remote wastewater treatment facilities throughout the region to better match the needs. So now what we're doing is we're actually able to treat the airport's waste much more effectively and treat the resort's waste. So if airport's sending down a heavier sludge, then you can build the treatment need right there, as opposed to having that all go down to the waste treatment plant. You specifically treat your waste locally. It allows you to then, to go through and actually then regionally produce waste and better manage your treatment. The other piece to it that we think is terribly important is you can manage reuse there. So when we talk about reuse, we talk about the fact that we lose in this large centralized wastewater treatment plants is the whole reuse component of it. Well, here what you're doing, you're matching your reuse need also locally. So let's say, for example, you want to use it for toilets. Well, you can run it through a membrane here if you want to do it. You can treat it to whatever level you want, but it stays within the system. And so now you have reuse on a local level. And then from a sludge perspective, every wastewater treatment plant produces sludge. And what you can use in this scenario is sludge enriched, composted, and can be used locally for be it garden cover or composting or vegetable gardens or what have you. So now we're talking about a closed loop system. All right, we talked about the highlights there. So talk a little bit about what we do at Basswood. Basswood was founded in 2004, as Edward had said. We have 40 million gallons of sewage, 45 million gallons of sludge processed to date. Our discharged water is greater than EPA standards, and we, from a sludge perspective, knock down sludge greater than 70%. It's automatic and remote, so you don't have to be there when you manage it. The Basswood Technology, the interesting thing about Basswood is a lot of processes treat either one way. They treat an aerobic process or they treat an anaerobic process. But nature doesn't break down bugs that way. Nature breaks down bugs in a hybrid environment. So what our system does is it creates an aerobic environment, a noxic zone, and an anaerobic environment, much like the way a stream would break down or waste. So what happens is we're much quicker able to break down waste in a way that allows our footprint, the size of our units, to be much smaller, which allows us also to do it much more economically, and also from an energy footprint standpoint, do it at 40% the cost of what your typical activated sludge or wastewater treatment plant does. So these are these numbers. So a Basswood treatment plant will come in about 70% less than an MBR plant. It's 40% less than a energy usage from a activated sludge plant. And package plant high rate anaerobic or aerobic is what you see a lot of times in hotels. So from a resort standpoint, if you're treating waste sufficient enough to use as an effluent standard, you use a package plant, and the Basswood system saves it by 115%. I got 1 minute. All right, so I'll just wrap up here. So, the Basswood advantages: substantially lower acquisition and lifestyle cost, significant sludge reduction, lower energy costs, as we just said, 40% lower usage, smaller footprint, little or no odor, the ease of operation, significant, absolute water reuse, and greatly accelerated product deployment time. I think the last thing, just to sum it up, the key here is when we look at waste is that the existing systems that we have deployed around the world or in the developed world are broken. We need significant infrastructure costs just to get them back up to speed. What we view is the best way in order to move forward in the developing world is to provide a format that is not broken, one that works, and that is, water use is incredible in the way in that we have to use it more efficiently, and you either price it into the equation, or you have to find a way in which to more effectively use it. And so we think that by tapping in water use on a remote standpoint, reuse, that it's a much more efficient model.